Okay, here is a refresher over all things polar conversions. I know it says polar algebra, but we do that with polar conversions. Okay, so we start off with some coordinates, right? Polar to rectangular. So a polar coordinate is in the form r comma theta, and your rectangular needs an x and a y. Okay, so of course we have a point. When we plot this point, we're going to first go to 120 degrees in relation to the positive x-axis. So there's your 120 degree mark. And then you're going to go away 1, 2, 3, 4, 5, 6, 7, 8, 9. So here's the coordinate 9, 120. We're going to change that into an x, y. So to do that, we of course drop your vertical line for the x component, and we drop your horizontal line. Sorry, there's the y component, and the vertical line is the x component. Okay, of course this is a 90-degree angle, and these are the two components that we're going to find. And it turns out that every time we do this, the x value, the x coordinate, is the radius times the cosine of your angle. And the y coordinate is the radius times the sine of the angle. And we're going to put this into the calculator using the correct mode. All right? So our radius is 9 and our angle is 120 degrees, which means in our calculator we have to have it in degree mode. And then the y value is 9 times the sine of 120 degrees. Okay, so put your calculator in degree mode, and this is going to be your answer. A negative x value, because we're in the second quadrant, so x should be negative, and a positive y value, because we're in the second quadrant, and y should be positive. Okay, we have a degree as our angle, we have a degree as our mode. Okay, now this next one is negative 2 pi over 3. This is a radian angle measure, so you need to be in radian mode, because your calculator will tell you the wrong thing if you are not. So we have negative 2 as a radius and negative 2 pi over 3 as your angle. Okay, so we should have an x coordinate of negative 2 times the cosine of negative 2 pi over 3. And we should have a y coordinate of negative 2 times the sine at negative 2 pi over 3. So these go right into your calculator. Or if you want to do it exact, you'd find the cosine value fraction at negative 2 pi over 3, which I believe is negative 1/2. And then this one's going to be negative root 3 over 2. Okay, but we're just going to use our calculator and see what it gives us. So here's our decimal approximations, right? 1 is not a decimal, but it's good. So the cosine is negative 1/2 times negative 2 is positive 1, and the sine is negative root 3 over 2. So this is the decimal approximation for root 3. Okay, so if your teacher wants an exact answer, the answer is root 3, and if a decimal is fine, then there's your decimal. Okay, now let's go the other way. So here is your x and y. This is negative 5 and 8. This is your x and your y. So let's plot this real quick because it matters where it is. Negative 5 is left of your origin and positive 8 is above. So there's our coordinate, negative 5, 8. We're going to try and find the radius and the angle formed with the positive x-axis. Okay, that's the two things that we need. The radius of your line, aka the hypotenuse of a right triangle. And we're going to find the angle formed with the positive x-axis. That's important to understand, that it's the angle formed with the positive x-axis. So we find the radius by doing the Pythagorean theorem, which says negative 5 squared plus 8 squared. Okay, so positive 25, because squaring things makes them positive, plus 64 is the square root of 89. And that is a perfectly fine answer. Okay, now what we're going to calculate is not our angle. It's actually going to be this reference angle. When we use our inverse tangent, we're going to calculate this from our right triangle. So alpha equals the inverse tan of 8 over negative 5. It's always the y value over the x value. Okay, and hopefully you're going to be in degree mode so that we can have an answer in degrees, because you don't really understand what radian angles mean. So we're going to do something that you do understand, which is degrees. So inverse tan of 8 divided by negative 5 is negative 57.99. So let's just round up to negative 58 degrees. Okay, which is not your answer. We don't have a negative angle in the second quadrant. What we've just found is that angle. Okay, and that's not our answer. Our answer is this one. So we find our answer by adding 180, right? So it's a negative already. So if we add 180 to our negative, that will tell us what our reference angle is. Sorry, our angle, which is 122 degrees. So as a polar coordinate, this is the square root of 89, which is the radius, and a 122 degree angle formed with the positive x-axis. So let's move on to number 4. Number 4 says positive 2 and negative 6. So positive 2, negative 6 is a fourth quadrant coordinate, okay, where we're going to find the radius once again. And in this case, we're going to find this angle, which is okay, right? This is going to be a negative angle because we're in the fourth quadrant and tangent is negative in the fourth quadrant, which is going to be an okay answer. So let's do this one. Pause the video. I'm just going to show you the answer in 3, 2, 1. Radius of root 40. And an angle, because we're in the fourth quadrant, negative 71.6 is a perfectly good angle. Okay? But you could have also had the positive angle, which when we add 360 to this, is going to be a 288 degrees. So if you want the positive one, then you add 360 to your negative angle, and that will tell you the positive angle formed going all the way around from the positive x-axis to your given angle. Okay, let's look at our polar equations. So here we have the equation that the radius equals negative 2 times the cosine of our angle. Remember, we want to create things like r squared, we want to create r cosine, or we want to create r sine. Those are the three things that we are able to replace. So in this case, we're going to multiply both sides by r. That is our strategy in order to, number one, create r squared, but also to create r cosine. So r times r is r squared, and then we're going to write this as negative 2 times r cosine theta. Okay? Because we can replace r squared. R squared gets replaced with x squared plus y squared. That is its equal. The radius is a Pythagorean theorem equality. And I can replace r cosine theta. That's equal to x. The x coordinate is r times the cosine of theta. So we are creating things that can be replaced. Okay, and this is all you need. This is your answer right here. Okay, you don't need to simplify it into point, center, and radius form of a circle, but know that this is a circle equation. So let's look at another one. Here we have r equals 6 cosecant theta. Okay, remember we want to make an r squared, or we want to make r cosine, or we want to make r sine. Okay, well, cosecant is pretty close to, right, it's related to sine. So I can replace cosecant with its sine equivalent. The cosecant is 1 over the sine. I don't want cosecant in my polar equation, so I replace it with 1 over sine. And now with a little bit of algebraic manipulation, we're going to multiply the left and the right side by sine. Okay, and of course sine divided by sine is 1, so that's a pretty easy cancellation. So on the left side we have r times the sine, and on the right side we just have 6. Well, look at that. I have created something that I can replace. And hopefully you recognize that r times the sine of theta can be replaced with y. So my final answer is y equals 6. That is my rectangular equation for my polar r equals 6 cosecant theta. Okay, how about the other way? So here we have, where to go? Oh, over here. So sorry, I just did numbers 7 and 8. Back to number 5. Whoopsie. This one says x squared plus y squared equals 36. So hopefully we know that we can replace x squared plus y squared with r squared. Right? That is a true polar equality, that the r squared, the radius squared, is the hypotenuse of a right triangle, so it equals the x coordinate squared plus the y coordinate squared. And now to solve for r, we simply have to square root both sides. And we get a final answer of r equals 6. This is the radius of the graph of a circle with a radius of 6. Okay, and then number 6, here we have a linear equation, 2x minus 5y equals 4. So I can immediately replace the x with r cosine theta. And I can replace the y with r sine theta. And everything else stays the same. So now I have to solve for r. Notice that both of these terms have a common multiplier of r. So when they have the same common multiplier, I can factor that r out from both of my terms. Because I can't solve an equation with 2 r's in 2 separate places. So I need to combine them into 1 r by factoring. So my final operation would be to divide both sides by this entire subtraction. 4 divided by 2 cosine minus 5 sine. And that is good enough for us right now. We can leave our answer like that. Okay, and our last concept is plotting. So here we have 7 points. Let me write them again in nicer form. So we have a mix of radians and degrees, and we have positives and negatives and positive and negative radiuses. So remember, these are all r comma thetas. There's a radius and a degree. And this is how we're going to plot them. We're going to plot them on this polar graph. So let's do some labeling. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 full circles, but then we have a couple. This would be your 9 circle, and that would be your 10 radius circle. Okay, and then let's count how many angles we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're dividing 180 into twelfths. Okay, so 180 divided by 12, well, that's 15. So each of these is 15 degrees. So there's 15 and 30 and 45 and 60 and 75 and 90 and so on and so forth all the way around. There's all your angles. So our first coordinate was, let's see, what was our first coordinate? 9, 60. That means we're going to go up to this 60 degree. Right, we're going to come up to 60. And then we're going to count away 9 from the center in a positive direction, which is towards 60. 1, 2, 3, 4, 5, 6, 7, 8, 9. Turns out to be here off of your standard graph, but I'm pretty sure you can still figure it out. Okay, there's point A, 9, 60. Okay, B is at 2, negative 210. So this is how we do negative 210. So here is positive 210. So we're going to go up to its mirror. Okay, we're going to find the mirror of 210, which is up here at 150. So 150 is also known as negative 210 degrees. So this is the line that we're going to put our dot on that happens to be 2 units away from the center. So there is our coordinate 2, negative 210 degrees. Okay, next we have negative 6, 3 pi over 4. So in case you don't know, 3 pi over 4 is also the 135 degree. Those ones are equivalent. Okay, so normally we would count from the origin towards 135 or towards 3 pi over 4, but because we have a negative angle, we're going to count away from. So we're going to go along the 315. So this is our line that we're looking at, right? This is the 3 pi over 4. So we're going to go in the exact opposite direction. 1, 2, 3, 4, 5, 6. 6 units in the opposite direction of 3 pi over 4, right? We're walking backwards while looking directly at 3 pi over 4. So make sure that you are tracing carefully that exact opposite line to get the correct coordinate. Okay, number 12 says 4, 11 pi over 12. Well, since we've broken these into twelfths, 165 is 11 pi over 12. We just have to count how many twelfths we have. So in this direction we go 1, 2, 3, 4. Here's our coordinate for D at 4, 11 pi over 12. Now one that we don't have on our unit circle, and that is negative 3 pi over 8. Okay, but our brain can tell us, and it has before, that pi over 8 is half of pi over 4. Okay, pi over 8 is half of pi over 4. So when we come back over here, right, this is your pi over 4 line, your 45 degree line. Since it's negative, right, we're going in this direction for our negative angles. So here, halfway is negative 1 pi over 8. That means this is negative 2 pi over 8. And if we come halfway, here is your negative 3 pi over 8 angle. Halfway between negative 45 and negative 90. 3 pi over 8. And we're going to go 3 units, which is not very many, but it's in the middle. So right here in between your 2 given lines, this is where we're going to find point E. 3, negative 3 pi over 8. Okay, point F says negative 7, pi. So we're going to come around to the pi, which is 180 degrees, and we're going to walk towards, or away from pi, rather, 1, 2, 3, 4, 5, 6, 7. Right, we're walking away from pi. So that's where we're going to find F. And then G is negative 30. So negative 30 is the same as positive 330. And we're going to go away 8 units, which is, oh, it's going to be exactly there. So there is your G point. And there's everything you never wanted to know, but need to know for your quiz tomorrow about polar conversions from polar to rectangular and back from rectangular to polar. Okay, goodbye.